Good morning, good afternoon, good evening. Whatever time this particular video finds you, just do yourself well to calm down, properly listen to this video, because this is one of the best videos you'll ever see explaining the use of battery bus bar in your solar inverter installation. So let's get to it. I've made several videos advising people to emulate the use of bus bar in their solar inverter installation, but I've come across few videos where bus bar is being put in place in some installation and they still experience a system failure. So in this particular video, I'm about to teach some of the benefits and how to properly use your battery bus bar in your solar inverter installation. So this particular diagram here is the first. This one consists of three lithium-ion batteries and a inverter and two separate bus bar, one negative and one positive. And this second diagram here too is where they have a exception of how you can actually use connect your battery without the use of a bus bar. Maybe you have two batteries and you want to connect it without the use of a bus bar. This is the diagram for it. And this last part here is to tell you the benefits. I will try as much as possible to keep this video short, so just relax and watch this video to the end because it's going to be a very long one. So let's get to it. The first thing you have to do when you have your battery arranged, whether it's wall-mounted batteries or whatever type of battery you are using, when you have your batteries arranged here, the first thing you need to do is that you get your cables and cable lock. Then when you're about to cut your cable for your batteries, make sure your battery are properly arranged. That is the first step. And when you arrange those battery, you look at the battery bus bar, you look at the last battery, the battery that has more distance to the bus bar. That is the first one you get to cut the cable. You measure it and you cut. Let's say this one now, because this one, according to this diagram, this one actually have a bit distance to the bus bar compared to these two. So first of all, you cut this particular cable for this positive here that is going to this positive. You cut that cable first. Once you cut this particular cable, this is the cable that you are going to use as the sample to get this other cable, because one of the principles of getting a bus bar is that the cables you are going to use for this particular connection, all the cables that are going to this particular each of these bus bar, have to have the same length to give this your bus bar a very good effective functionality. So you cut this particular cable, you measure it, you cut, you measure, you cut, make sure they are all in the same length. Even this one that is very close to the bus bar here, make sure it has the same length with this particular one here. That is your first step. So once you have cutting your cable, you connect them to this particular bus bar. Your positive goes to this positive and your negative comes to this negative here. Once you have done that successfully, the next step is this MCB breaker that we have here. The MCB breaker is coming to this particular bus bar that you have here. Then over here you have your negative coming this way and you have your positive coming this way. But I noticed that a lot of engineers, they normally get it wrong when you get to this particular part. Now if you have a bus bar and you have these 3 units of batteries here, you have a bus bar. If you, let's say these are 15 kilowatts lithium ion battery, 15 kilowatt lithium ion battery that you have here, these batteries are 15 kilowatts, and these cables that you use for this particular lithium ion battery are 35 cable. If you use 35 cable for this particular lithium ion battery to connect it to the bus bar, if you are coming from this NCB breaker to this particular bus bar, you need to use a bigger size of cable. Let's say 50 or 75 That is one thing that a lot of installers get wrong while connecting their bus bar, because you need to understand that this particular lithium ion batteries here, they are different units, not one lithium ion battery. And once they are going with this particular type of cable, if you are taking energy from this particular bus bar, because now you have, if this battery is 200 and this one is 200 and this one is 200, now you have 600 amps going out to this particular inverter. That is number one thing you need to understand. So while you are taking this energy out to the inverter, the cable that you are going to use to take this energy out need to be a bit bigger than this particular cable here. I will say the reason later in the benefits in this particular part of the stuff. And then this particular cable too that will be leaving your MCB breaker to your inverter need to be at the same size as this one that took the energy from this bus bar unit to the MCB breaker. So if let's say you use 75 for this one, you have to use the same 75 for the one that is going to the inverter. And the main reason for that is that most of the inverter we are using now, the hybrid inverters that we are using, for instance, they come with higher charging capacity. And now if you are sending current to this particular bus bar here with the same amount of cable capacity that you use for your lithium ion battery, there are high chances that those cables will be overstressed and they can lead to fire outbreak or leading to the cable getting overheated. So that is basically how you connect your bus bar. These are the steps you follow, and from here you go to your um, BMS connection ports and you connect your BMS and other stuff like that, and you are good to go by following this particular principle of connecting your battery bus bar. That is it. Now we now have an exemption. For instance, when you have a lithium ion, 2 lithium ion battery and your MCB breaker with an inverter that you want to connect, then you now notice that this particular lithium ion battery has two terminal connection. Let's say the negative has two terminal connection, the positive has two. The same thing with this particular battery. I saw a video from Electrical Beast that made that, how you are going to connect your lithium ion battery if you don't want to use a bus bar, and when you come across this particular type of battery. So now if you have something like this and you don't want to make a use of a bus bar, there is a way, because this one is very tricky. This one may be like actually mess with a lot of installer brain. So there is a way you have to like follow to get your proper result from it. Now you already have this particular two terminal here, and you have your MCB breaker with your inverter. So the first thing you have to do is that if your positive is here and the negative is here, then you have the same battery too beside it. First thing you will do is that you take from this particular negative to your MCB breaker, and you take from this particular positive to your MCB breaker. Why you are doing this? Because taking it to one particular lithium ion battery will bring this particular lithium ion battery. Let's say for instance now you take this positive here and you take this negative down here, before you now start looping from here to here, like from this particular one to this one, then from this particular one to this one, it's going to create a sense of more closer connection to this particular inverter. And with that, when you have heavy duty load on this particular inverter, it's going to drain more energy from this particular battery compared to this. And when you are charging the batteries too, it's going to charge this one more faster compared to this. But if you want to like make it to work properly, like you want to give it the functionality of that bus bar without having a bus bar there, you take the negative from one of the battery and you take the positive from one of the battery. Then from this second terminal here, you loop the negative to this negative here, and you loop this positive to the remaining one positive terminal of the bus bar. Then the same principle to also apply. As you are looping it, make sure if you are going to use a 36 mm or 35 mm to loop this one to this place, make sure this cable that is going like this and this one that is going like this are 50 mm. The same principle applies to it too, because this particular battery is coming with a higher current and is taking a higher current more than what this cable is plating. So you definitely need a bigger cable to serve this battery. If not for that, you overstress the cable, and that can actually lead to fire outbreak or the cable being overheated. So that is that. And the last thing you do is to like connect your inverter to the MCB breaker, connect the negative to the MCB breaker, and you make sure that if you are using like 50 mm for this connection, you have to use the same 50 mm for this too as well. So then you do your BMS connection port. That is basically all about it. So now let's go to the benefits of what you'll be like, the since you are going to be enjoying once you have this particular system, this type of system setup. The first thing you notice is that you will equalize the resistance coming from the, just like I said earlier, that this particular connection you see here is going to like help your inverter to understand that all these batteries here it will give them charging the same time and also discharge them at the same rating. If not the same, the difference won't be that much from each other. It's going to create a perfect balance on these particular batteries, and none of the batteries lifespan will be shortened. That is one about it. And the second thing is that the charging equalized, like it creates a clean and more organized cable management. That is number two. So when you have a bus bar here, this is going to like, like when you are connecting lithium ion batteries and you are using like these high duty cables, it's going to create a system in which there's a lot of cable flying around. But when you have this your bus bar, you can even hide your bus bar below, like at the back of your batteries, and you are going to see that your installation is going to look more neater and cleaner, and it's going to reduce voltage drop and what do they call it, when you have lithium-ion batteries connected to your system, it's going to reduce voltage drops and create more efficient power flow. What this actually means is that once you have this bus bar in between your lithium-ion battery and your inverter, is going to reduce your voltage, like your losses that you are going to be having from each of these batteries, because now you have already separated the load from each of the cable. Now the cable are not longer stressing themselves, and you have already used a bigger size of cable from the bus bar to your MCB, and from your MCB to your inverter. So that is actually going to reduce a lot of stuff, and it's going to like ensure safety. Like when you decide to like use lithium-ion battery and you are trying to jump cable from one terminal to the other, from one terminal to the, especially those lithium-ion battery that comes with only one single cable terminal. When you are trying to, if you decide to tie two cables from here to this particular spot, it's going to create a kind of I don't know how to say it, it's going to create a kind of loose head for this particular battery terminals, and this can actually stress the cable and lead to fire outbreak. But once you have your bus bar here, this tightening of this particular battery terminals will be very easy for you, because you have only one cable coming here, you have only one cable coming here, then going to the terminal, and you know inside the terminal you have all these micro points, tiny points for each of the battery that you want to use, and this is going to like ensure more safety on the particular installation, and it's going to secure the connection port too as well. It's going to secure the connection port, and it's going to simplify isolation and fuse connection. Like if you decide to like put fuse, like this one, this an isolator, this MCB breaker too, MCCB breaker, you can use this as an isolator. For instance, now you want to work on your inverter, or you want to take the inverter to a service center or something like that, or anything goes wrong, it will be very easier for you to like switch this particular stuff off, and also like disconnect one of the battery, or maybe one of the battery has issue. When you switch this one off, you can easily disconnect one of the battery from this particular port. Imagine that you loop all these batteries together, and this one at the middle here is the only one that come up with an issue. You need to start like disconnecting each of the battery separately for you to like bring out this particular one. But what this particular battery bus bar creates for you is that you can easily like just disconnect the BMS connection, that is the CAN port, and then you disconnect your battery from here, just remove it, and you take it to the service center. Once you are done with it, you bring it back. So I believe that you guys actually find this video helpful, and if you want more video like this, just tell me what you want us to have a discussion about, and I'm going to create a video for it. Thank you for watching this video to this very end.